Okay, we're going to go ahead and get started. I just wanted to do a quick check. If somebody could verify, either Al or Ross, since I can hear you, if you're able to. I'm just going to go ahead and get started. I just wanted to do a quick check. If someone. Apologies. Actually, I just have one technical detail I need to sort out real quick. Okay, trying again. Apologies. This is live streaming on YouTube. So I just had to take care of a little feedback I was getting from that. So you are able to watch this as a live stream on YouTube if you have any issues with watching this through Zoom. So, but if somebody could actually just quickly confirm that you are able to see my slides, that would be fantastic.
Yep, can do.
Perfect. Thanks, Ross. So this is Mike Ward here from R3, and appreciate everybody joining us yet again. We have a few things to go through today, so I'll try and be quick and to the point on my part. I was just going to make a brief mention about SIBOS, where I am today, and where a number of us are from R3. Ross is going to run through one of the API changes that was made that a few people have had questions on, talk about the rationale for that and the path forward. Kasia and Al are going to talk about a bigger item, more in length, around network map changes that they have been working on. And then last, we're going to close out with the demo of a trade finance demo that Cais has done for us. And Cais is going to run through that demo. That demo will be online and available to everybody at some point in the near future. So the very first thing, the small piece of news from R3 is just that we are attending the SIBOS conference this year. So those who are not familiar with SIBOS event, SIBOS is a banking conference. I believe there's something close to 10,000 attendees. It's quite an interesting event. And of course, the biggest subject up here this year is yet again is blockchain. So it's quite interesting. R3 has been front and center on that, participated in a number of panels. We did choose not to get a booth this year. And a big reason for that is that we, of course, work through our partners to come to market, and our partner success is key to us. So we've been attending through other people's booths, which has been quite interesting. It allows us to talk about how Corda as a distributed ledger platform can be used in a business context and how it can solve the problems for the attendees here, which has been fantastic. So we've received a lot of great feedback. You can find us if you are out here. We're in a number of booths. We will be around Finastra, Calypso, primarily over at the Hewlett-Packard Enterprise booth, and then also spending a little bit of time over at the Hyperledger booth. So please, if you're here, come try and find us. So the next piece of business, I'm going to pass over to Ross. And Ross, I'll let you talk, and I'll just leave a slide up to talk about the IsRelevant API. And we don't have any slides for this, but we did want to make sure we just address this quickly. So over to you, Ross.
Cool. Yeah. So we've had a number of people trying to use IsRelevant, trying to use the Vault service to store states that are not owned by the node identity. And we've had a lot of sort of problem between what we thought you'd do, what was meant to do, and what everyone else thought it was going to do. So the Vault was envisioned to hold the states of a node, as in the ones you own. And for a while, we had it storing any states it witnessed. And the problem with that is you create an incredible amount of data. And in particular, you can't necessarily reliably delete this data at the end of its life cycle, because you might see a transaction where a state is issued, but you might not happen to witness the destruction of that state if you're not actually the owner. So IsRelevant was introduced to restrict the states down to the ones that are owned by the identity of a node. And everyone then come back to us and went, yeah, but we were using it for other states. So at the moment, we're introducing sort of a hybrid model. The main set of states in the vault will remain as the ones that you own. But we're currently looking at introducing the idea of an observable state. And this is one where a second set of people, separate to the owner or the participants, sees the state and keeps a copy. And the intention here is that if you have a contract that is designed to be observed in this sense, you inherit the observable state interface and provide a list of those parties. There is no enforcement of that observation. There's a sample coming that will actually show you what that enforcement could look like, but we don't enforce it at the API level. And this, so I'll come back to observation and enforcement in a second. So this introduces a new status for states in the vault. So we have consumed, unconsumed, and a new one of observed. Because you aren't guaranteed to know when an observed state is consumed. So we don't pretend that we know if it's consumed or unconsumed. We just say it's something I observed. So that's coming. That's in work in progress at the moment, and there's documentation coming in for that. There's a sample coming in as well to illustrate how it can be used, and also to illustrate how requiring an observer node is sent a copy of this transaction might work for anyone who wants that and needs it. So if you're just sending copies to a node for indexing or for just general information, you can do that just by making it an observable state and putting that observer into the state. And if you need to enforce it, there are worked examples on how you might do that with extra commands to separately illustrate that, as it say, by the observer that a node has been observed the transaction. I hope that makes sense. I'm going to just drop my email address into chat. If you have any questions or want to talk to me about this, please get in contact. Just type this out now.
And Ross, you might actually direct people to the public Slack channel. Would be a great place if you're comfortable talking about it in a public forum.
Right now, can I ask for people to email me? But
no problem.
Yes, I'll also be talking to people on Slack, just not today. Richard's asked, that's a very good question. When can you start seeing the code change in the code? It should hit master this week, I hope. If it doesn't, I'm realizing I'm on leave next week. So early next week, if I can find someone to hand over to, otherwise it'll be the week after. But definitely imminent, sort of, we're targeting 1.1/2.0, definitely targeting 2.0, and I think it's scheduled to be backported to 1.1. 1.1, of course, being the bug fix and improvement release to 1.0, and 2.0 being the main update. Yes. And to answer Matthew's question, do we envision the observable state being referenceable from the transaction logic? Absolutely. So you'll be able to have the verification logic look for the observation interface on a state and find its observers from there. Yeah, absolutely.
Ross, what does it look like from the Corda developer's perspective? What changes?
You just add this new interface onto the state and have any parties that need to see a copy of the transaction returned from it.
And that's it?
Yeah, it's a new interface. So it just mixes in with all the other ones. So you've got things like ownable state, linear state. I can't remember the other ones off the top of my head, but it's just another state interface that you add on top.
Sounds great. Very easy to use.
Okay, that's the hope. Okay, great. I'll pass back to Mike there. That's okay.
Excellent. Thanks, Ross. So we were going to talk next about a change that we're working on in the background, but maybe one of our larger changes in the near term around the network map. So we had Kasia and Al, we're going to present on that. So Al, I believe you're presenting from your computer. So it would be great if you guys can take control.
Yeah. Yes.
Perfect.
Is it okay? Am I sharing?
But it's not this one.
Yeah.
Okay. Okay. So hello. We are part of the network map redesign team, and I'll try to give some high-level overview now of our current thinking on networks and participants' interaction in that network. So, as an introduction, there are a few definitions. Business network is, you can think about that like a freelance projects, and there are participants that have certain goal and transact certain type of assets between each other and using their own solutions, Corda's. There's a set of rules between them, and they are not always want to include other participants, or the one node might want to participate in many networks like that. There is also a compatibility zone, and of which you can think as a high-level network, which is run by Arri, and it joins all of these small participants' network and lets them easily cooperate, interoperate, and enables the asset mobility between them. To have that, we need to provide some common network standards, consensus, which are the special nodes, special notary nodes that can be trusted on the network, identity service, which is a domain, and also network map, because it stores the well-known identities on the network. So network map service also enables nodes to discover each other. So it maps the parties and certificates to network addresses and enables the communication. Previously, we had the implementation that was okay for prototyping, and we had a special node, one node that ran network map service. It holds the connection to all of our nodes. So the startup procedure was each node on the startup connected to this node, registered for updates, then fetched the current state of the network and cached it locally. It wasn't persisted on the node. Then it listened for new additions or modifications to the network from this network map service node. There were a few problems with that. One of them was that if network map node was down, you were not able to start the node and to be a participant of the network. The message protocol was AMQP based, and we also had a notion of advertised services, which I will tell more about on the next slide. So advertised service was an action that node advertised on the network and said, I will perform this for everyone. And we decided to get rid of it since version 1.0. Why? Because it wasn't that well thought. It was also a privacy issue, because you as a node, you might not want everyone know what exactly you run, and it wasn't well defined, because you could put there anything you wanted. So the main use case for that were oracles, which are replaced by in Corda, you directly know who the oracle node is, so you can configure it and contact this party. Network map service, which is being removed. Notaries, which are the special case on the network, and they should be treated differently. There are trusted services, and it shouldn't work like that. Someone advertises notary, and you don't know who he is. And cash issuers, and this concept was useful only for testing.
Okay. So for the record, I'm working on the network mapper design team together with Kasia. Going on with the topic of the presentation. So first of all, so what are the reasons because of which the architecture we have don't meet our use cases? So first of all, this design doesn't scale. So we have a single network map node chosen somehow, which needs to keep an open connection with every other node in the network. And this is in the long run unfeasible. We would have a node whose only job would be, to keep sockets open to half the world. It's also a single point of failure. So if the network map node goes down, then the network goes down. Everything goes down. No messages can be sent or received. And it's also probably not such a good idea from a security standpoint, as who runs the network map node clearly has more say on what nodes can do, or can stop nodes from knowing each other in a somewhat arbitrary manner. There is no good choice for this network map node in general. Also, if the network map server goes down, nodes can start. The startup of the nodes is slower. And furthermore, it's a design which doesn't allow for networks where not every node see each other. Like currently, the network map node is just a node which contains every reference to every other node and gives that away to every node which comes along asking for it. So what do we want for our network map? What are the problems which we're trying to solve? So first of all, we want something which is highly available. We want to be always able to reference nodes. We want to be always able to send messages to any node. And we want a design which is able to scale. Like we want to have as many nodes as we possibly can. We might want to have 100,000 or maybe millions, who knows. From a data delivery point of view, we like to possibly outsource that to a CDN. Specifically, we don't want to have to implement, a content delivery network ourselves. So we just want to use a standard infrastructure and just pay for that. The network data, everything related to the network will be signed. So whenever a node produces some information about itself, that is signed. Therefore, network operators and others actors on this data can't change it. We've also introduced a concept of network parameters. Network parameters define the network, more on that later, and every node who is willing to participate in a network must agree on those network parameters. If they don't, they can't send or receive messages. Also, we want to have network data being persisted locally on the node, either on this current database. We want this because if the node goes down and comes back up, it doesn't have to go and ask anyone to find the addresses and the references of the other node. It can just start sending and receiving messages from anyone. And also that should help us in the case, should some other piece of the infrastructure goes down, the node is perfectly capable of keep on sending and receiving messages from other nodes, assuming they're up. And also there won't be a special node. Like the network map node was a special node which was having a special role. We want a network where every node is equal. There's no node which is more important than the others. Going into more details about the new design. So we want the network map to be a collection of signed files, which nodes will download on a per need basis. These files will be distributed via standard HTTPS protocol, no RMIs, no funny things. The doorman will have an extended role specifically. So the doorman was the server which used to sign the certificates for new nodes. And now furthermore, the doorman will receive the signed node infos from every node in say another part of the registration process. And then the doorman will ensure that those data will be retrievable via the CTN provider that we will pick. All data which is passed around in the network is signed by whoever created that. The nodes will download via HTTPS the data they need from network map, and then we'll obey the expiry data and keep on checking if a new node come to be and download the new ones they need. Nodes will store locally everything they have, and the network parameters, which are same data as the rest, will define the network and will be treated in a very similar way as the rest. I mean, they're chosen by the network operator as a whole, but other than that, it's signed and distributed following the same principle as outlined above. Going into more detail about the network parameters and the compatibility zone, which will be identified with CZ for short. So compatibility zone is a set of nodes which have the same network parameters chosen or agreed by a network operator. So first of all, network parameters specify a minimum Corda version that your node must have in order to be able to join the network. The network parameters contain a list of notaries so that one node can just become a notary one day, or you can just say that you had a transaction notarized from a notary of your choice. And the set of notaries is known in advance, and no new notaries can be created unless you go by a procedure to change the whole set of network parameters on which every node has to agree. We set a maximum size for messages and the transaction size. And we do also have an epoch, which is needed for updates. Basically, at a certain point, we'll be running version N, and then there will be a process which will be defined in more clarity later, in which it will be switching the whole network to version N+1. The idea is that once a node agree to the network parameters of the compatibility zone, they can easily exchange message among themselves, knowing the notaries which are going to authorize the transactions, the code that others are running to some extent, like they know a minimum version, and also the size of the messages. The specific about the network parameters negotiation. Currently every node has to retrieve a network parameters file. So a node will need to have the network parameters file specification for the network they want to join. We haven't currently defined a specific way of distributing those. They won't change often. Anyway, in general, the network operator should make those available somehow. And the network map knows which is the current live set of network parameters. We will just distribute the hash. So the change of parameters is a more complex procedure. So nodes have to agree on a new set, and this should be an out-of-bound process primarily. Once there's a significant agreement, we will define specifics later on. The new parameters file is created, signed, and distributed offline, and so that every node has that. And then on a given date, which is part of the decision which has to be taken as part of the new operator negotiation, that day the network map will start claiming that the network parameters version has increased. That's the epoch. That's basically a bump in the epoch value. Should one node not accept these new network parameters, they will be cut off the network. Okay. First of all, we will have a slightly different configuration for how node will work in production in the real R3 net, and how do we see node working on when you have them running on your machine, or when you want to bring up a small set of nodes which you want to experiment with. So the production case will work like that. So every node will create a network info file. A node info file, which basically contains the Corda address, its party name, which is a Corda X500 name, the certificate, something else I can remember, and we'll send that to an HTTP server, controlled by the network operator. Then the network operator will make it available, will publish a list of the registered node hash, and then the network map service at specified times will poll the CDN via using the hashes to find the new node infos which have been published in the meanwhile. So nodes will store the node infos they have seen in a database. And in case of restart, nodes will readily have access to that data. So there's
You have to go through the door.
yeah, what controls are in place for updating individual node sign data? They go via doorman. So
It's a normal network registration
yeah, it's a network registration procedure. The doorman will not accept the changes, like you can't change your name or your keys without that being issued by the doorman in general. And for testing and development, what's going to happen is that when a node starts up, it will just write on disk its own signed node info. And a new folder has been created in every node root directory, additional node infos. And nodes will constantly check for new files in that directory. And if there are newer files than the ones they've seen, they will load those. Every node is capable of talking with other nodes, which are stored under additional node infos. So there's a question which I didn't read in its entirety.
I think we can already switch to questions.
Yeah. Let me just.
Now, actually, there's a Q&A window if you can look at when you're complete. Sorry. When you take questions, there are 2 questions up in the Q&A window.
Okay, so the presentation is over. So is that now or at the end of everybody else's presentation?
I think no.
Okay. Okay.
Not yet. So network parameters for now have only the notaries, transaction size, message size, epoch, platform version, but we're still thinking about what should be included as to crypto requirements.
Yeah.
Oh, okay.
And you taking this?
I need to read it.
And actually, if you can read that question also, Kasia,
Okay, so the first question was, does the network parameters include any crypto requirements, algorithms and supported hashing, and etc.? So for now, they're not. And accepting actually. So for the network parameters, the process is out of. So the next question is, what is the governance process workflow for agreeing on network parameters and accepting, rejecting new nodes? Sounds like it is all agreed out of bounds. So network parameters, indeed, it is out of bounds, and the whole agreement process looks like the network operator distributes the network parameters to the nodes, and if you agree on that, you can put it into your nodes directory, and after certain time, which is also set, the network operators does check how many nodes accepted the new network parameters, and then there is a date when you move to the new parameters, and if you didn't accept them, you're not able to participate in the network, because that's what defines the whole compatibility zone.
Yeah.
Okay.
And there's just a couple more in the chat window. Unfortunately, they split Q&A and chat, but I'm not sure if you guys can address those. What controls are in place for updating an individual node's signed data, as an example?
Yeah, so from Sharat, what controls are in place for updating an individual's node's signed data? That's the same as the registration process. So the doorman needs to agree to the new data. So basically what we expect to change are the hostname and ports nodes run on. There will be another design for the chain certificate revocation. We don't have flashed that out yet. So that will be another case in which node info is going to change. And I think we will also support to some extent changing of the name of the node, but again, we haven't yet decided which constraints are on that. So I hope that answered the question.
Excellent. Thanks, guys. So I think we can move to the next section. If anybody else has questions, feel free to go up in the public Slack and post questions. So public Slack's a great way to get an answer for that. I should remind everybody, for questions you have kind of more generally on your implementations, always go to Stack Overflow. But thanks, Kasia and Al. That was a very good overview. Much appreciated. So all of our demos we're building are going to be available for everybody's use. So we'll put these up on the web in the near future here. But Case is going to do a run through of his demos. We did a quick recording of this. Case is here also for questions. And then following up in a later session, we'll email you thanks for registering, because we're able to follow up and let you know when this content's available. So this is a trade finance demo. So Case is going to run through it. And then, of course, the code will be available for you shortly.
So today I'll be demonstrating.
Oops, apologies.
So today I'll be demonstrating how Corda can help solve problems within the trade finance sector. In particular, we'll be focused on one key facilitator of international trade, known as the letter of credit. For those wondering what a letter of credit is, a letter of credit is a letter from a bank guaranteeing that a buyer's payment to a seller will be received on time and for the correct amount, given that the seller in turn fulfills all their obligations. I.e., it helps remove a great deal of the credit risk involved in international.
Yeah, is this a bit quiet for everybody?
That one.
Somebody is speaking. Roger, I'm going to mute you, Roger.
International trade. It's easy to imagine why there'd be a great deal of resistance in a manufacturer agreeing to produce and deliver X many goods at great cost to itself without guarantee of payment. And on the flip side, you can imagine why a buyer wouldn't want to commit payment up front without the guarantee of the manufacturer even remaining in business until such time that the goods are delivered. So what this means is that the banks essentially take on this risk, and if a buyer is unable to make payment on the purchase for whatever reason, the bank will be required to cover the full or remaining amount of the purchase. Now, of course, once upon a time, a handshake would have been sufficient for this, or a contract with a personal house emblem embossed in hot wax. However, over time, given the nature of international dealings, including factors such as distance, differing laws in each country, and difficulty in knowing each party personally, the use of letter of credit has become a very important aspect of international trade. So let's begin with a brief overview of each screen, beginning with the seller. So the seller can see their orders, purchase orders submitted, and goods shipped from previous orders. Up here you can see the wallet. The seller doesn't hold any cash, and the seller's on port 10,016. The nodes are actually running in the background for this demo. So over to the buyer. Buyer's running on port 10,013, and you can see the buyer is actually holding some cash. This is cash on ledger, and this does link up with our wildfire demo, if you've seen that. The key bits here are the applications awaiting approval and the live orders. So over to the issuing bank, they can see the active letter of credit and any applications awaiting approval, and the advising bank just views live letter of credit. So we begin the process by creating a purchase order. Pretty straightforward. We can attach a PDF or anything else if necessary. We'll just go ahead and hit the autocomplete, and we'll create the purchase order. So that creates that state on Ledger, and we'll shortly see that that's shared with the buyer and only the buyer. So the buyer now sees this purchase order, and as pre-agreed with the seller, they'll I'll now go ahead and apply for a letter of credit. So we'll do that. Up here we can see some of the parties that are part of this transaction. It just happens that the issuing bank is called the issuing bank, and the seller is the seller, and the buyer is the buyer, and the advisory bank is the advisory bank. Let's go ahead and submit that. In doing so, we're creating an application for a letter of credit that the buyer and the issuing bank can see. So there's the application. The advising bank and the seller at this point are not aware. So if we go back to the issuing bank and we view the application, assuming everything's good, we can go ahead and approve that. In approving the application, we now have a live letter of credit. What this means is that it's a state on ledger that's shared with the advising bank, the seller, and the buyer, so they all have this overview of the letter of credit. And there's the seller as well. And at this point in time, we don't have any documents attached. So here's the seller's view. So they have a look and they're satisfied. Now let's fast forward to some point in the future where the manufacturer has completed production of the goods and they're now ready for shipping. One of the key documents that need to be produced is the bill of lading. The bill of lading is one of the 3 crucial documents used in international trade, and for those wondering, lading essentially means loading, but specifically refers to the loading of cargo aboard a ship. It's a negotiable instrument and serves several purposes. It's a conclusive receipt, i.e. an acknowledgement that the goods have been loaded. It's evidence of the contract of carriage. And perhaps most importantly, it serves as a document of title to the goods. And okay, what you see here is sort of typical of a bill of lading document. There's the option to add an attachment. We'll just go ahead, hit the autocomplete, and we'll submit. Okay, now we can add the packing list. The packing list is essentially an itemized detail of the package contents. It serves to inform all parties, including transport agencies, government authorities, and customers, about the contents of the package and helps them deal with the package accordingly. Now, in a more in-depth demo, we'd probably expect there to be an additional node on the network, i.e. one that represents the carrier. This is so that they can countersign the bill of lading or the packing list or any other documents that require input from the carrier, or confirmation rather. Now if we go over to the advising bank and see things from their perspective, over here on the bill of lading we can see they now have the exact same view as input by the seller, and the key bit is that the owner is still the seller. They still have title to the goods. If we just hit the timeline button, we can see at what point that was created. And packing list, again, same thing. Now, if we go to the issuing bank, since these states are shared amongst all participants, they can also see the exact same thing again, owner as seller, and there's a timeline view. And of course, the buyer. Giving everyone this great overview. Having the bill of lading in digital form on ledger like this is pretty key, and really great for the trade finance industry, because fraud is so rife. Even the unassuming step of having an application and having irrefutable proof as to who signed it and the issuing bank countersigning is also quite key. Just earlier this year, Vietnam suffered one of its largest cases of fraud in the seafood industry. There were reports that a New Zealand-based bank colluded with another company, and they were taking seafood shipments from Vietnamese companies, but then refused to pay. A letter of credit was used, and the ramifications were not insignificant. Several companies went bankrupt, and essentially, in a nutshell, the Vietnamese exporters submitted documents showing that they'd fulfilled their obligations, and then were refused payment by the intermediary bank on the grounds that the buying company's signature in the sales contract with the Vietnamese exporters was different from the one used to open a letter of credit with the bank, which is pretty crazy to think that in 2017 companies can go bankrupt off the back of there being a discrepancy in a written signature. And taking things even further, the company had taken one of the copies of the bill of lading and used it to obtain the goods from port. So obviously, having a bill of lading digital form like this, where everyone has a view of exactly who the current owner is, and that sort of timeline view, really is a huge step forward. Okay, so assuming now that the advising bank is satisfied, having seen the documents, they can go ahead and pay the beneficiary, which is the seller. So there we can see the amount being deducted, and the seller is the amount owed minus the advising bank's fee. And if we have a look now, the status, seller paid, and the bill of lading, and this is key, the owner is now marked as the advisory bank. If we have a look at the timeline view, we can see that it's moved from the seller to the advisory bank. If we go over to the issuing bank now, again, they have the exact same view. The advisory bank is the current owner, and same with the buyer. Again, see the same thing, and the timeline view. Every node, every participant sees exactly the same thing. So the issuing bank can now go ahead and pay the advisory. Again, see the amount deducted. And it's this whole sort of delivery versus payment thing that we can do. Everything's an atomic transaction. As soon as payment is made, the owner on the bill of lading is also switched, and there we see it. So the owner now is the issuing bank. And again, have a look at the timeline view and can see how it jumped from the seller to the advisory bank to the issuer bank. And here we can see the advisory bank is now marked as being paid, and we see the issuing bank's view, of course, with them as owner. And finally, we can move on to the buyer. So the buyer can now settle, and in settling, this essentially completes the life cycle of this particular letter of credit. We can see the amount deducted up there, and the issuing bank receives this amount, so they're now up 3,000, which is they're taking from being involved in the deal. The issuer is now paid. Having a look at the bill of lading, we can now see that the owner is the buyer. And again, timeline view, we can see how we moved from the owner being the seller to the advisory bank to the issuer bank, and finally to the buyer, who now can go to port and collect their goods. And on that note, I think this brings the demo to an end. Thanks. So
great. And thanks, Cais, for the demo. So as we noted, the demo, first off, is very relevant for the current situation at SIBOS. Of course, trade finance being one of the subjects that's under discussion here. So if you're at SIBOS, swing by the HPE booth, and we can give you what we can around that demo, walk you through it, and then we'll communicate with you all, let you know when that source code goes up, so you can take it for yourself, tear it apart. Of course, it uses cache and other states behind it, so it's a fully functioning Corda. So thanks for the help on that, Cais. Good presentation. Apologies for the audio, everybody. We'll work on that for the next time. If you have any Q&A, you can jump them in now, drop some questions in now. Otherwise, we will probably close the session in just a minute. I don't see anything up there. Thanks for your time, everybody. This recording will be available immediately on YouTube if anybody needs to rewatch any part of it. Otherwise, you can find us on the public Slack channel or put your technical questions up on Stack Overflow. Thanks, everybody.